Hello, everyone. My name is Varshu Nukala. Today, I wanted to present and explore a subject that's both complex and deeply impactful, and that's addiction. When I hear the addiction, or when most people hear the addiction, it often conjures images of substance use like drugs, alcohol, nicotine, or smoking. However, addiction is a faceted condition that extends far beyond substances, encompasses behaviors, habits, and patterns that can disrupt lives and alter our own brain chemistry. The purpose of my research is to delve deeper into the mechanisms of addiction, to understand how it takes root in the brain, and to explore the broader implications for both individuals and society. By better understanding these processes, we can move towards more effective treatments and prevention strategies. Okay, let's talk introduction. So introductory wise, I just want to make something clear about substance use disorder and addiction. So the definition of addiction is a condition or fact of being dependent on a particular substance or activity that produces intense activation of the reward system. So in general, it basically means where we're very dependent on a particular act or substance and we keep aching for it. And there is also, I want to talk about the difference between substance use disorder versus behavioral addiction. I know it seems pretty straightforward, but I just want to make it a little bit more clear. Substance use disorder is where you use substances like alcohol, nicotine, smoking, whereas behavioral addiction is more something you gain attached to, like an activity. Like gambling is this type of type of behavioral addiction that most people get addicted to, which is compulsive gambling. So let's begin to talk about dopamine. Dopamine is a neurotransmitter that is released when we do an activity that's enjoyable and beneficial, and it is involved in various functions, including sleep, motivation, mood, and most importantly, the reward system. So the dopamine is usually called the brain's feel-good neurotransmitter. And dopamine is like integral part of our reward system and is released in response to activities that bring us pleasure, whether it's eating, social interaction, or achieving a goal. However, this same system is hijacked when in addiction. When someone uses an addictive substance, dopamine transmission increases significantly, creating an intense feeling of pleasure and euphoria. But this isn't just about good feeling. Over time, the brain starts to adapt these surges to dopamine and it becomes less sensitive to everyday pleasures. For example, your favorite video game that you play every single day might end up being really boring, or meeting up with friends would be tiring and it's not as enjoyable as it used to be. And so the brain is literally requiring more of the substance to achieve the same effect. This leads to the vicious cycle where normal activities no longer bring joy and individuals become increasingly reliant on the substance and don't feel anything at all to everyday activities. Uh, Next, let's shift our focus to the opioid signaling system. So, opioids are naturally occurring chemicals in the brain that play a crucial role in pain relief and emotional regulation. So in this picture right here, we see a membrane, so it's part of the cell, and we see the opioid receptor right here, and this is the opioid, natural opioid from the brain. And when both of them two combine together, they usually block the pain receptors. Um, and they like reduce the pain and increase the symptoms of pleasure and relaxation. However, when someone uses an opioid drug, like such as painkillers like heroin, morphine, prescription painkillers, these substances mimic the body's natural opioids, but at like a much larger scale. This can lead to dependence on the drugs or painkillers that are prescribed and eventually addiction. As the brain becomes increasingly reliant on these external sources for pain, relief, and emotional comfort. So here you see this would be a natural case in this picture, but when seeing it from a painkiller perspective, you'll have a lot of these opioid receptors coming in and they'll continuously keep blocking out pain signals more effectively than a natural would, obviously. But that feeling uh, leads to more progressive addiction rather than a natural case. So moving on, addiction cycles. So addiction doesn't happen all at once. It develops through a cycle with three distinct phases. Um, the phases being binging slash intoxication, withdrawal slash negative effect, and anticipation slash preoccupation. So let's break this down. The first phase, binge slash intoxication, the individual experiences the rewarding effects of substance or behavior. This is usually when individuals take that first drug and they're feeling that high, rewarding feelings of gratification, relaxation, all those pleasurable feelings. This is followed by the withdrawal slash negative effect phase, where the absence of substance leads to negative emotions, stress, and discomfort. So, this is where individuals usually tend to form depression or just very a sad, tired um, feeling overall. And then after this, it's the anticipation slash preoccupation phase. Um, and the individual here becomes consumed with thoughts of obtaining the substance use again, um, and which can affect relationships if the individual just keeps thinking about it. It can affect relationships, school, workplaces, and this just gives us a crucial reason to know why addiction, addiction in a more deeper level, so we can help others. And again, this cycle is self-reinforcing. The discomfort of withdrawal drives the individual back to the substance, which temporarily elevates the negative feelings, but ultimately it strengthens the addiction more. Next, we have diverse studies on addiction. So our understanding of addiction has been enhanced by studies involving both humans and animals. Um, Human studies have given us insight onto how addiction manifests and affects behavior, while animal studies have allowed us to explore the underlying biological mechanisms. One key takeaway from these studies is identification of specific brain regions involved in addiction, such as the basolateral amygdala, which is also known as the BLA, the ventral tegmental area known as the VTA, and lastly, the nucleus accumbens, also known as the NAC. To break it down a little bit more easier, the BLA is known for conditional fear. So it plays a role of fear memory, and the VTA is composed primarily of dopamine neurons, which is released downstream regions, which in turn controls reward consumption, learning, memory, and addictive behaviors. These areas are critical in regulating reward, emotion, and decision making, which are disrupted in addiction. Lastly, the NAC, the nucleus accumbens, is a region known for communication between each of these regions, in particular inputs from the VTA and the BLA. So in this diagram, we see the BLA as being right here, the VTA here, and then the NAC. So the VTA will push flow the dopamine neurons towards the NAC, and the BLA will also go to the NAC, and they kind of communicate with one another, forming the NAC is like almost an area where the dopamine neurons kind of combine on little thoughts in your mind, which form around those thoughts. And this is what makes you choose what you want to do next, whether you want to eat cake or if you want to eat cookies. And those dopamine neurons help make decisions. Um, Next, we have substances and their effects. While the mechanisms of addiction are similar across different substances, each has its own unique impact on the brain and body. For instance, opioids not only alter pain receptors, but also affect emotional regulation, leading to higher rates of dependence. Cocaine, on the other hand, increases dopamine levels by preventing its reuptake, resulting in intense but short-lived euphoria. Alcohol and nicotine are also have profound effects, pretty similar but it has its own set of challenges for treatment. And then understanding these differences is crucial in developing targeted interventions, so more personalized recovery plans for individuals that address the specific needs of those struggling with addiction. Next is the global health perspective. Addiction is not just a personal issue, it affects us globally. It's a global crisis. It's all around our communities and nations, and it's like all over internationally. Substance use disorders affect millions of people worldwide, leading to significant social, economic, and health-related consequences. Organizations like World Health Organization, also known as WHO, are working tirelessly to address this issue on a global scale. They're developing strategies to reduce the harm caused by substance use and to provide support for those affected. However, there's still so much work to do to prevent addiction and to provide effective treatment options for those who need. That is why coming together and just sharing and spreading awareness about addiction is truly important on such a deeper level. So, in conclusion, addiction is a complex and multifaceted condition that affects individuals and societies in profound ways. By understanding the underlying mechanisms, such as the role of dopamine and opioid signaling systems, we can begin to unravel the complexities of addiction. As we move forward, it's crucial to continue research in this field, to develop more effective treatments and create more personalized and supportive environments for individuals who are suffering with addiction. Together, we can work towards a future where addiction is better understood, better treated, and come up with more interventions, and ultimately less prevalent in addiction. Thank you.